Okay, so now we're going to do equivalent values for each of the following. So to do an equivalent of values, the way I taught it, oh, I have no idea what just happened. So the way I taught it was to do a box, line, box. And this is just, this goes here, so sine goes here. This is the sine, depending on what quadrant your angle's in. And then this is the reference angle. Okay, so ASTC, sine of 330, so 330 is right about here, if you need me to do that, there. So it's in quadrant 4, so cosine is the only thing that's positive in quadrant 4, so sine has to be negative. Sine is not cosine. Then the reference angle for 330, so you draw, what do I need to get back to 360, so this is 360, so it's 360 minus 330, which is 30 degrees. That's an equivalent value. We're not looking for exact values here. That's next. So secant of negative 230, so we put secant here, the reference goes here, and ASTC, depending on that, goes there. So negative 230, remember this is 0, this is negative 90, negative 180, negative 270. So I'm in this quadrant somewhere. Okay, so that means I'm where where sine is positive. Remember, secant is the reciprocal of cosine. It's the reciprocal of cosine, which is not sine, so it's got to be negative. And then the reference angle, we want to figure out, basically take off the 180, and we want to find out what's left. We want to figure out this angle right here. And we always want the positive, but the way we figure it out is we take out the 180 of it. So I think that's 50. So an equivalent value would be negative the secant of 50. So these two are the exact values. So this is where you need your radical 3 over 2 and whatever. So it's the same thing as we did before. It's the same thing as the last one. You know, you figure out your ASTC, cosine of 210, so 210 is somewhere right here. So this is at the tangent quadrant. Cosine is not tangent, so we know it's going to be negative. And what's the reference angle here? We want to get back to 180, so it's 210. Getting rid of the 180. Oh, that's 210. So that's 30. So it's negative the cosine of 30. The cosine of 30 is radical 3 over 2. There we go. Okay. Tangent of negative 330. So same deal. Negative 330 goes right to here. Because remember, this is 0, negative 90, negative 180, negative 270, and then this is negative 360. So we're in quadrant where all of them are positive, so tangent is positive. The reference angle here, we have to get to 330, to 360 from 330, so that's 30 degrees. Remember, this is always, reference angles always have to be positive. So the tangent of 30 is radical 3 over 3. Okay, I feel like I cut these out of yours, but I'm not sure. I don't know. This isn't, I didn't have the file, so I'm just faking it right now. So 230, if you don't have this one, then sorry. So we just want to draw 230. So sketch the angle 230. So remember, a sketch is just got to be basic. So this is 0, this is 90, this is 180, this is 270. So 230 would be somewhere in here-ish. Remember to draw the curve, since it's positive, it's going counterclockwise, and put that arrow there on the end. That's it for that one, so that's 230. And they want us to label the reference angle with an R. Now right here is the reference angle. You should need to actually find it. So it's minus 180. So that is 50. It's interesting. So it's 50 degrees is your reference angle, and I'm labeling it with an R. find the value of the trig function indicated. So here I want to find the tangent. I already know that the cosecant is 25 over 7. So you got to do a little math here. So remember, this is what I like to call the hidden right triangle. You have to know that cosecant is hypotenuse over opposite. Remember, it's the reciprocal of sine. So since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So we draw our little right triangle. This is where my theta is going to be. It's just the way I like it. You can put it wherever you want, except at the right angle, that is. So we want to do hypotenuse is always there. Opposite, well, I know that's adjacent, so this is opposite here. Got to do the Pythagorean theorem. 25 squared plus x squared. We don't know what this is. This is my x right here. Equals, oh yeah, that's good. Awesome. Thank you. Thank you. Sorry, 7 squared plus x squared equals 25 squared. I'm working this all out, and x winds up equaling 24. You can do all the math. Anyway, so if I want to find tangent of theta, tangent is opposite over adjacent. So remember, this is opposite, hypotenuse, adjacent. So opposite is 7, and adjacent is 24. They're not mentioning quadrants or anything, so we assume it's all in quadrant 1. Cosecant is 5 over 3. Find the cotangent. So cosecant is the reciprocal of sine again. Yeah, sorry. I did the same one. Okay, so cosecant is the reciprocal of sine, so it's hypotenuse over opposite again. So the opposite is 3, the hypotenuse is 5. I'm putting my theta there. So doing the Pythagorean theorem, do all the math, and x winds up being 4. So we want to do cotangent. Cotangent is the reciprocal of tangent, so that's adjacent over opposite. So this is the opposite, this is the adjacent, so I do 4 over 3. Sorry if you hear my dishwasher in the background there. Alright, I have to be able to see this. If an angle is in standard position and its terminal size passes through the point negative 512. So when you're doing this, you just have to basically sketch it a little bit. And so just sketch where negative 512 is. So negative 5 is right about here. 12 would be somewhere up here. So remember, that's where the point is. That's where the angle comes out. And then you always have to draw your angle, your altitude with the x-axis. Okay, it's not perfect, but you get the idea. So the theta is always here, and then we just put the points. This was 5, even though my sketching stinks, and up is 12. Remember, we went up 12, so this is the same 12. And then we need to label, or we need to know this is adjacent. This is opposite, so we need to figure out what the hypotenuse is. We do the Pythagorean theorem again. 5 squared plus 12 squared equals x squared. And this turns out to be 13. Just doing the math. So this is 13. So if we want to find all 6 trig functions in simplest form, so remember, this is what I like to do. What you decide to do is up to you. I do sine, cosine, and tangent. Then I do the reciprocals, cosecant, right next to them. Secant and cotangent. I like to do the sines first. So you know that you are in quadrant 2. So here sine is positive. So these are the only 2 that are positive here. Everything else is going to be negative. And after that, then we just do our OA and H stuff. So sine is opposite over hypotenuse. So this is the flip. Cosine is adjacent over hypotenuse. Cosecant is the flip. Tangent is opposite over adjacent. And cotangent is the flip. There you go. So I'm skipping 46, going to 47. So 47, same basic problem as the other one, just different quadrant we're in. So it's in 8, negative 15, so we're in quadrant 4. So we're going to say that's 8, that's negative 15. They meet here. So remember, draw your angle. If that was an angle, it would have come all the way around here. Then we drop the altitude to the x-axis. This is our right angle now. So theta is always here with the x-axis and the angle. I labeled my 8 and my 15 there, but the 15 should be here. 8, 15, you do the Pythagorean theorem. 8 squared plus 15 squared equals whatever. It is, x winds up being 17, doing all the math. So this is our opposite, adjacent, hypotenuse. And now we just write them all. So sine, cosine, tangent. Cosecant is the flip, secant is the flip, and cotangent is the flip. So here we're in quadrant 4. Quadrant 4 is cosine is positive. All the rest are negative. And then we just do it. Sine is opposite over hypotenuse. So then we flip it. Cosine is opposite. That's an 8 over hypotenuse. Flip. Tangent is opposite over adjacent. And then we flip. Do you need some? Okay, and then finally we do these. Each, we have a triangle. C is the right angle. This is just the way the program is. C is not always the right angle, so just be aware of that. But in these, it is. So that means when we draw this, this is C. They tell you, so I'm going to make this A, because this is talking about cosecant of A, so that's always the angle that I want to deal with. I like it down there, it's just me. Remember, little a is across, so this is little a. I don't like this arrow here. Sorry. Little b is across from 12, so that goes here. So we have our opposite and we have our adjacent, but we don't have the hypotenuse, and cosecant, which I feel like I've done way too much of, is hypotenuse over opposite. So I do need the hypotenuse, so I need to figure it out. So it's 12 squared plus 16 squared equals x squared. Doing the math, it turns out x is 20. Okay, so then this is 20. So then all I have to do here is cosecant of A is hypotenuse over opposite. They want us to reduce this guy. So what, 4 goes into both of those? 5 over 4. And then 51, same basic thing. Math isn't going to be as pretty. We got some radicals. Cosine of A is what we want. Right angle. So I'm putting my A here. It's told that C is the right angle, so this is B. So the side opposite B is 2. Side opposite A is 8 radical 3. The cosine of A is adjacent over hypotenuse. So I have the A. I need the H. So we got to do the math here. You got to be careful when you're squaring 8 radical 3. Make sure the 8 gets squared too. Plus 2 squared equals x squared. Okay, just to keep you on track, 8 radical 3 squared is 192 plus 4 is equal to x squared. So 192 plus 4 is 196. pretty sure that is 16. Oh, 14. Sorry. All right, whatever. So x squared is 14, or x is 14, excuse me, I took the square root. So cosine of A is adjacent over opposite. I mean, over hypotenuse, whatever, I wrote it right. And then we reduce 1/7. All right, I think I did it all right. Yeah. Have a wonderful day. Good luck on the quiz.